Alright guys, so today we're going to go over scientific notation. Has anybody ever heard of scientific notation before? No? You've heard about it? Okay. Oh, because I said it last week? Did anybody look at it? Get a chance to look at it over the weekend? Yeah? Okay, no problem. So I guess let's start off with the definition for scientific notation. It's pretty simple. I think you guys are going to do great with this. Thank you. Scientific notation Okay, so there's your definition. Scientific notation is a method of expressing very large and very small numbers as a product of a number greater than or equal to 1 and less than 10 and a power of 10. Okay, so it sounds confusing. It's not. Okay, so I got you guys right now. So let me highlight a couple things. So I highlighted that right there. And that. So if you guys have your highlighters, go ahead and take them out, highlight it. If not, underline one of them and circle the other one. So I'm going to do this over here. I'm going to write an example. Let's go with a really big number. 8 1 0 0 0 0 0 0 0 0. Okay. That's how much money I wish I had.
But no, I don't wish I had that. That's too much.
No way. That'd be awesome.
That's
Like Bill Gates money.
All right, so let's just say that you guys are in college, okay, and you're having to write a paper, and this paper is talking about how far away the nearest planet that could have life is, how many light years or how many miles or whatever kind of unit you're using, and you're using this number, and you have to use this number quite a bit. If you were writing an essay or a paper or whatever you want to call it, would you like to write this number over and over and over and over and over?
no.
That would be really annoying, wouldn't it? Okay, so what you do instead of having to write this whole number out, what you do is you write this in scientific notation. So what we're going to do is we're going to take this thing and we're going to write it in scientific notation. To write it in scientific notation, you have to do the following. So I'm going to take the number, and I'm going to locate the decimal first of all. Where's my decimal right now, guys?
After the last zero.
So I have my decimal right there. And I want to put my number in a way that it is greater than 1, but less than 10. So what numbers are between 1 and 10, guys? 8, 9, 7, 6, 5, 4, 3, 2, and 1 point whatever, but greater than 1, right? Does that make sense, everybody? Okay, so I need to move this decimal point, and all you have to do is count with me. Count with me. 1,
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
So I moved it 11. Why did I stop there? Yeah, exactly. 8.1, right? It's less than 10, but it's greater than or equal to 1. So my number is going to be 8.1. That's why I put it in the highlighted, so it's 8.1. That 8.1 is greater than or equal to 1, but less than 10. And then it's going to be a product of power 10. So 10, this is the stuff that's in, this is what's going to be in blue. But it's got to be to a certain exponent. Which exponent do you guys think it's going to be?
As many zeros as there is there?
Not as many zeros. How many times did we move our decimal point?
11.
Did we move it 11?
No. Or yeah.
Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we moved it 11. So it's going to be 8.1 times 10 to the 11th power. That, guys, is scientific notation. That's it.
Look at that. You're not honest. Worrying so much about it.
Colin?
Why did you multiply by pound?
That's how you do scientific notation. So a scientific notation is always going to be a number that's greater than or equal to 1 and less than 10. That's why it's in yellow. You see the definition up there? And it's a product. Product means multiplication. And it's a product of a power and 10. Yeah.
I remember my friend showing me sometimes it can be negative.
It could be negative, and that's what we're going to do right now. Okay? So that's a very big number, right?
Yeah.
We'll call this example 1. Let's go with example 2. Let's just say that after you finish writing your essay about possible living like a planet that could sustain life and it's very far away, now you're writing an essay of what type of life could possibly live there. And it's not things that are really big, it's things that are very small, like on the microbial level. Okay? So now you're saying, hey, there could be some microbes that live over there, and they are 0.00000000042 centimeters or inches or whatever big. They are very, I don't know, that's what we're going to see right now. That's a very small number, right? Would you like to write that number over and over and over? That would be very what? That would be very annoying, right? Okay. So what we're going to do is, again, we are going to write this as a number between 1 and 10 times a product of 10. You guys ready to go? Just count with me. Just count with me, guys. Ready? By the way, where do I want my decimal to go? But where? In front of the 4, between the 4 and the 2, after the 2, after the 4? Okay, so count with me. I know you guys can count. Let's try that again. Ready, go.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12,
Why'd I stop there?
Because
Because
it's
2 is
4. 4.2 is in between, it's less than 10 and greater than 1.
Exactly. So it's going to be 4.2 times what?
Negative 10.
Not negative 10.
10 to the power of negative 12.
10 to the power of negative 12.
wow. Look at
So I want you to pay attention to this. When you moved your decimal to the left, like in the big number, so the decimal moved to the what?
Which one?
The big number.
Oh,
To the right.
Decimal moved to the right.
No, the left.
So when the decimal moved to the left, we get a what kind of exponent?
A positive?
We get a positive exponent. On example 2, which way did the decimal move?
Right to the right. Oh,
What kind of exponent do we get?
negative small.
That's basically scientific notation, guys.
We did a little work there.
For now, yes.
Oh, Chris.
It gets harder.
Even if I hadn't said that, I still would have gotten harder. I feel like it's my fault.
Yeah, but you brought it up, so no.
Yeah.
Now we're sad.
And I take your part about giving us tests and asking questions about it.
Expanding scientific notation.
Yay!
So what we're going to do here is I'm going to give you a number that's written in scientific notation, and you have to write it out like how it should be. Does that make sense? So right now what we did was we took a number that was in expanded form and we wrote it in scientific notation. Now you're going to take a number that's written in scientific notation and you're going to expand it.
Couldn't you just add zeros to the amount of like numbers or something?
Okay, so how do I write that in expanded form? 7.4 times 10 to the 6th. Which way is my decimal going to move?
To the left.
Uh-oh. To the left or to the right?
To the left.
Okay. Now let's look at this back here. When our exponent was positive, did we have a big number or a small number?
Big number.
A big number. So if I move, I want you to pay attention to this.
Oh.
If I move to the left,
You get a
I'm going to get a very small number. So I'm kind of contradicting myself there. So no, I'm not moving to the left. Which way am I going to move to? To the right. So I'm going to take the number. I'm going to write it 7.4. And I'm going to move to the right how many times? Count with me, please.
1, 2, 3, 4, 5, 6.
Why did I only move 6?
Because it says 6.
It's times 10 to the 6, right? So in these little bubbles, I'm going to add zeros. So this number expanded is how many zeros on there? 5?
Yeah.
That's it. That's how you expand it. Go and try to expand that, guys. Here, let me rewrite that again. 8.2 times 10 to the negative 7. Exactly. So it's a negative number, so we got to move the decimal which way?
To the
And I'm sorry, not a negative number, negative exponent, I should say. How many times to the left? So 1, 2, 3, 4, 5, 6, 7. So this number, written expanded, is going to be 0.0. How many zeros? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 82. Are we okay with writing in scientific notation and then expanding from scientific notation?
Yeah.
We're good? Okay.
Oh no. Hey, are we having a test or a quiz on Friday?
What are we having, guys, on this stuff?
A quiz.
Quiz.
When?
On Friday.
So there's two times. There's two types of adding and subtracting in scientific notation. The first type, so I'll put type 1, is when you have the same exponents. And that's the one we're going to focus on today. That's the easier of the two. And then there's type 2, when you have different exponents. And that's what we're going to work on tomorrow. Yes? Go ahead, dude. So the one we're working on today is type 1, when we have the same exponents. And this is what I mean by it.
Is this on our weekly problem set?
What is it?
Is this going to be on our weekly problem set?
No, because we haven't done this yet. Weekly problem set is only stuff you've done. What do you guys notice about the exponents, guys? They're the same, right? Okay, they're the same. What are both of them? Times 10 to the what? So we can add these. If they didn't have the same exponent, we wouldn't be able to add them without manipulating them, which we're going to do tomorrow. But for now, they have the same exponent, so you keep the exponent. It's going to be times 10 to the what? Our answer is going to have times 10 to the what? And then we just have one thing left. We have our numbers that we have to add. There we go. So what are we going to do with these two numbers? We're going to add them. You guys all know how to add decimals? What's the rule for adding decimals? Line up the decimal. So 7.532 plus 2.17. And I can put a 0 there. So just add 2, 10, 7, 9. So my answer is going to be 9.702. 7 plus 2?
Oh. I got 5. I subtracted them.
Yeah, we're adding. Is there any questions on that?
You said 2, but you wrote 4.
Hmm?
You said 2, but you wrote 4.
I said, oh, thank you. 9.702. Sorry about that, guys. Any questions on that, guys? Pretty simple, right? Nothing crazy. Okay, let's subtract some. That's it. Can we subtract these the way they are right now?
Yes,
How come?
because they have the same exponent.
Same exponent. They're both times 10 to the 8th. So then I just do 4.12 minus what?
Minus 1.31.
Okay, in this case we are going to have to borrow. 2 minus 1, that's 1. 1 minus 3, that's impossible, so I'm going to have to borrow. 11 minus 3, that's 8. Put my decimal down. 3 minus 1 is 2. So how do I write this in scientific notation?
Hold on, I'm still doing the problem.
Gotcha.
Wouldn't it be 2.81 times 10 to the power of 8?
Times 10 to the power of 8 is correct. That's it, guys. Okay, now your area has some problems where the bases are not the same. We will cover those tomorrow. Okay, so the bases, when the bases aren't the same, we'll cover those tomorrow. But you can at least do, you can do about 70% to 80% of your area already. Okay, so that's it.